Hello everyone! In the previous video, we provided an overview of our ROS2 security robot. We're continuing our video series with building instructions for our ROS2 security robot. To begin, we purchased the Create3 educational kit from iRobot's online store, and you'll need Raspberry Pi 4 board with a heatsink and RP LiDAR A1M8 as well. We built the robot based on published documentation from the iRobot Create3 site and the ClearPath Robotics TurtleBot4 Lite. Here are the hardware specs list we are using to build our TurtleBot4 Lite modified version. The main difference is that instead of the OG-D camera listed in the specifications, we are using a white cube-shaped blink security camera. You can substitute it with any small 5-volt USB security camera that fits in a robot and can be plugged into Raspberry Pi's USB port to power it up. It could be Wise camera, for example. Therefore, as I mentioned earlier, in addition to the iRobot Create3 kit, we need to get RP LiDAR, a Raspberry Pi 4B with 4GB or 8GB memory with heatsink and USB cables. The iRobot Create3 kit includes a battery with a power distribution and charging dock. Here is RP LiDAR laser range scanner shown as well. Here we see all the resources required to build the robot, which includes Ubuntu 20.04 with ROS2 Galactic and all TurtleBot4 packages on Raspberry Pi 4, and also tutorials and examples. Please note, at the time when the robot was built, we were using Ubuntu 20.04 with corresponding packages. Now, Ubuntu 22.04 is available with ROS2 Humble, so you might want to consider upgrading to this version. If there is a sufficient interest, we can rebuild our robot with Ubuntu 22.04 and ROS2 Humble. Just let us know in the comments below. Let's start loading the operating system and software. First, download TurtleBot4 Galactic image to your Linux computer. This is zip file, consists of the Raspberry Pi 4 Ubuntu 20.04 operating system with ROS2 Galactic and TurtleBot4 packages. Now we have to install operating system and ROS2 packages on a micro SD card, which will be inserted into the Raspberry Pi 4 board. Choose a 16GB or larger micro SD card class 10. Load Balena Etcher to your PC and insert the micro SD card, then start Balena. Click Flash from File and select the image file you downloaded. Then click Select Target, which will be your micro SD card. Then click Flash, and in a few minutes the image will be loaded into your micro SD card. Now the card is ready to use and you can insert it into Raspberry Pi 4 for further setup. Now we can install ROS2 Galactic on your PC, whether it'll be laptop or desktop computer running Ubuntu 20.04 or Ubuntu Mate 20.04. Just follow the 4 steps: setup local and setup sources shown on the screen highlighted in yellow. Please note that if you're running Ubuntu 22.04, you will need to install ROS2 Humble, which is not currently included in this video. Continue with installation of ROS2 packages, which includes 5 steps highlighted in yellow, and then proceed to the environment setup, 1 step. We just completed ROS2 installation on your PC. Once ROS2 install, then install the TurtleBot4 desktop packages, which are highlighted in light gray on this screen. Now it's time to power up the robot. Place the Create3 onto its dock. The green LED on the dock will turn on for a few seconds and the Create3 robot should power on. Allow the robot some time to boot up. Wait for happy sound to play. From your desktop PC, connect to the robot via Wi-Fi fixed IP address of 192.168.10.1 over its VLAN 1 interface. Make sure Raspberry Pi connected to Create3 via included USB-C cable and also connected to the network router via Wi-Fi. Please note, Create3, Raspberry Pi and desktop PC must be connected to the same Wi-Fi network subnet. Always refer to Create3 and TurtleBot4 documentation as well. On Create3 robot, enter your 2.4 GHz Wi-Fi network and password in the corresponding fields. Click Connect, then click Application tab. On Create3 Robot Application tab, for RMW implementation, select RMW Fast TRPC SCPP and then click Restart Application below the Save button and wait a couple of minutes to complete restart. For more details on the robot buttons and indicator lights, visit the Create3 documentation. The screenshot is just for references in case if you would like to install Raspberry Pi 4 packages for the robot manually. It is essential to keep this documentation handy for troubleshooting and better understanding of the process. To summarize, we are using 2 sources of information to build the security robot: Create3 from iRobot and TurtleBot4 Lite from ClearPath Robotics. Before starting the robot, you might need to review the documentation on both sides to understand process flow. At this point, you can go back to my previous video and watch it again to refresh your memory on starting and operating this security robot. Please let us know your thoughts in the comments section below. Good luck!